Hi everyone, so today in this video we're going to be going over some related rates problems. So here's our first question. A 6 feet tall person walks away from a 6 foot tall streetlight at a rate of 5 feet per second. If the tip of the shadow is moving away from the streetlight at a rate of 13 feet per second, how fast is the person moving? So first we're going to model this situation. So we have a 15 foot tall streetlight and a 6 foot tall person, and the tip of the shadow over here is moving away at a rate of 13 feet per second. These two distances over here I'm going to represent with x and y because they can change. And in this case, we're solving for dx over dt because that's the rate at which the person is moving away from the shadow. Moving away from the street light. So now we're going to separate this larger triangle into two similar triangles. So we have one triangle over here, which is created with the ground and the street light. And then we have a smaller triangle created with the person and the street light, or the person and the ground. So now tan theta is equal to 15 over x plus y, which is also equal to 6 over y because the triangles are similar. And we can use this ratio to solve for the variables that we need to in this case. So because we're given that the tip of the shadow is moving at a rate of 13 feet per second, we can represent like the distance from the tip to the street light as a different variable. We'll call it s. And then we can simplify. 15 times y is equal to 6 times s, and we can differentiate now to get 15 times dy over dt is equal to 6 times ds over dt. And we know that ds over dt is going to be equal to 13 feet per second. So then we can plug that in and we get 15 times dy over dt is equal to 6 times 13, which is equal to 78. And then we can rearrange to get dy over dt is equal to 78 over 15, which is also equal to 26 over 5. So we have dy over dt, but we want to find dx over dt. So notice that in this step over here, we combined x and y, called it s, and then use this rate over here to find dy over dt. But now we're going to separate that back and then back into x and y to be able to solve for dx over dt with dy over dt, which we just calculated. So now we can cross multiply over here, and we get 15y is equal to 6x plus 6y, and then 9y is equal to 6x, and then 3y is equal to 2x. So then we can differentiate 3 times dy over dt is equal to 2 times dx over dt. So notice how we use dy over dt as sort of an intermediate between ds over dt and dx over dt. So now we can plug it in and we get 3 times 26 over 5 is equal to 2 times dx over dt. And then we can simplify and rearrange, and we get 39 over 5 is equal to dx over dt. And the units for this problem are feet per second. So our final answer is going to be 39 over 5 feet per second. Okay, so here's our next problem. An airplane is flying horizontally at an altitude of 10,000 feet. It passes over a radar station and is moving away at 500 feet per second. How fast is the angle of elevation changing when the plane is 10,000 feet horizontally from the station? assume the radio station is at ground level. So again, we're going to use a diagram to model this situation. So this point over here is going to be the radio station. This is going to be the airplane over here. So the altitude is 10,000 feet, which won't change. And this horizontal distance, I'm going to represent with x. Even though this question says that it is asking for the angle of elevation when the plane is 10,000 feet horizontally from the station, I'm going to represent it by x because that distance can change. And this is going to be theta. So tan theta is equal to 10,000 over x. And we can differentiate here to get secant squared theta is equal to negative 10,000 over x squared times dx dt. And this is also d theta dt. So we know that theta in this case is equal to pi over 4 because at the instant where x is equal to 10,000, tan theta is equal to 10,000 over 10,000, which is just 1. And we know that tan of pi over 4 is equal to 1. So theta is equal to pi over 4, and x is going to be equal to 10,000. And we know that dx over dt is equal to 500 because that's how fast the airplane is moving. So then we can plug everything in and we get d theta over dt times secant squared pi over 4 is equal to negative 10,000 over 10,000 squared times 500. So this cancels out and we get theta over dt times, so secant squared pi over 4 is going to be 2 over rad 2 squared, and this is equal to negative 1 over 10,000 times 500. So we can cross that out and make this 5. And this is equal to negative 1 over 20. So this simplifies to 2, and then we can divide by 2 to get d theta over dt is equal to negative 1 over 40. And the unit for this problem would be radians per second because we have an angle. And yeah, that's our final answer for this one. Okay, next problem. Water is being poured into an inverted conical container at a rate of 3 feet per minute. This cone has a height of 10 feet and a radius of 5 feet. How fast is the water level rising when the water is 4 feet deep? So again, we're going to use a diagram to model the situation. So the water height is going to be h, and then the overall height is going to be 10, and the radius is going to be 5. So we have two similar triangles again. One smaller one over here created with the water height and the cone, and one is going to be the total like cone size. So the smaller triangle is going to be h theta, and we're going to save, like, we're going to write this radius over here, this side, in terms of h. And the larger triangle is going to be 10, and this is going to be 5. And because these triangles are similar, the ratio of the sides has to be equal in both of them. So this has a ratio of 10 to 5, so which is the same thing as 2. So that means this side has to be h over 2 for the same to hold true. And now we can write our volume of water using the volume of a cone. 1/3 pi r squared, but in this case our radius is going to be the h over 2 squared times h, and this is equal to 1 over 12 pi h cubed. And then we can differentiate and we get dv over dt is equal to 3 over 12 pi h squared times dh over dt. And we know dv over dt is equal to 3 because that's how fast the water is being poured into the container. That's how our volume is changing. And then h is going to be 4 because it's asking for how fast the water level is rising when the water is 4 feet deep. And then we can plug all this in and solve. So 3 is equal to 1 over 4 pi times 16 times dh over dt. And then we have 3 is equal to 4 pi dh over dt. And finally we get our answer, 3 over 4 pi feet per minute, because that's the units that are given in the problem. So yeah, that's our final answer. So like, even though all these three situations were different, each problem uses the same process. We have to relate the variables, differentiate with respect to time, and evaluate at a given moment. And diagrams and models make it really easy to be able to do this. And following these steps makes related rates problems easier to handle. Thanks for watching.